Hello, and welcome to another video. Today we will be learning about composition of functions. First, we're going to review how to evaluate functions. So consider the function f of x equals 2x minus 3. Evaluate the following. The first one says to evaluate f of 5. So what I'm going to do is I'm going to take my input value of 5 and input it into my function and then simplify to get my output or my y value from it. So here I'm going to do 2 times 5 minus 3. You can also think of it as replace all my x's with the number inside of the parentheses that I'm evaluating. So this x right here is why it became a 5. After that, I'm going to multiply 2 times 5, which is 10, and then 10 minus 3, which will be equal to 7. So that's what f of 5 is. So when I input 5 into the function f of x, I get my output to be 7. For the next one, again, I'm going to do the same thing. So this will be 2c minus 3, because again, I replace my x with a c, and then I can't simplify any further. So this is my final answer. F of c equals 2c minus 3. For the next one, I'm evaluating f of 4a. So I'm going to do the same thing. F of 4a is equal to 2 times 4a plus parentheses minus 3. Again, I'm replacing my x with 4a. F of 4a will be equal to 8a minus 3. Same thing for the last one, but now I have two things or a binomial as my input. So I'm going to do f of 5x minus 1 is equal to 2 times 5x minus 1. And then don't forget the minus 3 on the outside. Use the distributed property. So when I do this, I get f of 5x minus 1 is equal to 10x minus 2 minus 3. So when I simplify that, that will give me 10x minus 5 since they're both negative. And this is 5x minus 1. Okay, sometimes in math, we will plug in a value of x into a function and then use that output or answer to plug into another function. Or it can be the same one. When we plug in the output y of the function back into the function is called a composite function, also known as a composition of functions, because you're combining two different functions into one. So for example, number 1, it says let g of x be equal to 3x plus 1, and then let g of 2 be equal to c. And then I am finding g of c. So what I'm going to do is I'm going to say that g of 2 is equal to c. I don't know what g of 2 is yet, but I can find it given the equation. So to find g of 2, I'm going to do 3 times 2 plus 1, or you can think of it as evaluating my input value of 2 into g. So that will give me g of 2 is equal to 6 plus 1, which is equal to 7. So this is what g of 2 is equal to. And then notice how I'm inputting that same function back into g again, because I want to find g of c. I know that g of 2 is equal to c, so I'm actually looking for g of 7, which is the same as g of c, which is the same as 3 times 7 plus 1. So that will give me 21 plus 1, which is 22. So this is an example of a composition of function, again, where you took your output and then converted it into your input here, and then evaluate it both times using g this time. It does make it a little bit confusing with the c, but when we do the examples, we won't be saying c, we'll be saying find g of whatever the answer was, making it a little bit easier. So there are two ways in which we can write composite functions. The first one is parentheses f of g together, and then x on the outside. And then the second one is to write one function inside of the other one. So in this case, it will be f of g of x. These two mean the same thing. Personally, I like this one better because it's easier to see and to know which one goes first. But you will see both on your AP test, so it's always good to rewrite from this form into this form, which is what I will be doing as we do the notes. So we will read this expression as f of g of x. So important note, when we're working with composite functions, we start on the inside. If you're talking about this one, so g of x is inside, so work that part first. After you find that answer, then you move to the outer function until you are done if you have multiple. If you look at this form, you're always going to start from the right and then go towards the left. So in here, g is on the right side, and then f is next. And then as you can see, again, you start with g here, start with g on the right, and then you go out to the next one, and then same thing here. So when we're doing this and we're finding f of g of x, we're going to evaluate g of x first, and then use the answer from g of x to plug it into f of x. So again, going in that order from the inside and then out. If you have to do it 3 or 4 times, you can do it multiple times or as many as you need to. So let's look at some examples with some equations. Again, this will be a little bit easier to do. So this one, for example, 2 says let f of x be equal to 3x minus 5 and g of x equals 2x plus 1. And then we're evaluating the following functions. So for the first example, I'm looking for f of g of 3. Again, it starts with the inside. So I'm evaluating what g of 3 is. So this is my g. So it'll be 2 times 3 plus 1, which will be 6 plus 1, which will be 7. After that, I'm finding f of that answer, or f of 7. So when I do it, it will be 3 times 7 minus 5. After that, I'm just going to find my answer. 7 times 3 is 21 minus 5, which is 16. So again, I know that f of g of 3 is equal to f of 7, which is the same thing as 16. So basically here you just put your second input with the function, and then that will give you the same answer. Okay, let's look at the next example. On this one, again, I'm starting with the inside, so I'm finding f of 3. So this example will be 3 times 3 minus 5, which will be 9 minus 5, which is 4. After that, go to the outer function, which I'm looking for g of 4, which will be 2 times 4 plus 1. So that will be 8 plus 1, which is 9. And then I'm going to say g of f of 3 is equal to g of 4, which is equal to 9. Okay, last one. I'm looking for f of 4. So again, start with the inside. So I'm going to do f of 4, which is 3 times 4 minus 5. So that will be 12 minus 5, which is 7. And then again, I'm plugging into f again. So I'm finding f of 7, which would be 3 times 7 minus 5, which will be 21 minus 5, which is 16. So I know that f of 4 is the same as f of 7, which is equal to 16. Please make sure that you show all your steps to make sure that you get the correct points if you're doing an AP test or a free response question. Example number 3 says use the equations for f and g in example 2 to find the expressions of the following. So I'm going to work them out in a similar way. So again, start with the inside. My inside is g of x. So I'm going to rewrite g of x, which is 2x plus 1. After that, I'm going to find f of my answer, which is f of 2x plus 1. And then I'm going to plug in 2x plus 1 into my f equation. So in this case, it will be 3 times 2x plus 1. And then don't forget the minus 5 on the outside from the equation. After that, I'm going to distribute this 3 to both of these terms. So that will give me 6x plus 3 minus 5. When I simplify, that will give me 6x minus 2. That's my final answer. So again, that's the same thing as f of 2x plus 1, which is the same as 6x minus 2. So for this step, you just kind of repeat that step and rewrite it. Okay, for the next one, start with the inside. I know that f of x was given to me, which is equal to 3x minus 5. And then I'm taking that and I'm plugging it into my outer function, which is g. So I'm looking for g of 3x minus 5. So when I plug it into g, I get 2 times 3x minus 5 plus 1. So distribute that out. So that will give me 6x minus 10 plus 1, which will be equal to 6x minus 9. So when I write this, I'm going to say that's the same thing as g of 3x minus 5, which is equal to 6x minus 9. So nothing really hard or complicated. It is the same process as before, but before we had numbers, now we have variables. So let's look at a few more examples. So here they gave me 4 different functions. H of x equals 2x minus 3. K of x equals x squared plus 4x plus 5. G of x equals square root of 3x plus 1. And then M of x equals 3x plus 2. So I'm evaluating K of H of 2. So I'm going to start with the inside and I need to find H of 2. To find that, I'm going to do 2 times 2 minus 3, which I know that H of 2 will be equal to 4 minus 3, which is equal to 1. And then I'm going to go to the outer function and then find K of 1. Again, K is here, which is going to be 1 squared plus 4 times 1 plus 5. So 1 squared is 1. 4 times 1 is 4 plus 5, which will give me 4 plus 1 plus 5, which is equal to 10. So I'm going to say that this is the same as K of 1, which is equal to 10 once I write my answer. Okay, for the next one, I'm looking for H of M of negative 1. Remember how I said you can always rewrite them as H and then M of negative 1 inside of my parentheses. So again, I'm going to start with M of negative 1. So going to M is right here. So it'll be 3 times negative 1 plus 2. So that will be negative 3 plus 2, which is negative 1. And then I'm finding the outer function, which is H of negative 1 again. Keep in mind that just happened to be the same number. It doesn't actually have to be the same number. So that will be 2 times negative 1 minus 3, which will be negative 2 minus 3, which is equal to negative 5. So that's the same as H of negative 1, which is negative 5 once I write it down. I will do the same thing for C, and I will rewrite it as with the parentheses. So it will be K, open parentheses, P of X. So same as before, I'm going to rewrite P of X, which is the square root of 3x plus 1. And then I'm going to plug that into the outer function, which is K of the square root of 3x plus 1. So looking at K, this is my function. So square root of 3x plus 1, quantity squared, plus 4 times the square root of 3x plus 1, and then plus 5. I am going to try to simplify this a little bit. So when I square this, the square root will cancel out. So that will give me 3x plus 1 from that. This one, I'm multiplying this, so I can just leave it as 4 times the square root of 3x plus 1. Again, these are together, I can't separate them. And then plus 5 on the outside. I do have some like terms here, so I can put them together and say this is 3x plus 5 plus 1, which is 6, plus 4 times the square root of 3x plus 1. So that's what that would be equal to once you write it down. So that will be k of the square root of 3x plus 1, which will be equal to all that. 3x plus 6 plus 4 times the square root of 3x plus 1. Okay, for the next one, we have some different representations. So they gave me the function for f of x here, and then they gave me a graph. They gave me the function of g of x here, which is a table. And then they gave me a piecewise function here, which is given to you by the function h of x. And then they gave me some information about k of x dealing with transformations. So here they're telling me that k of x is a quadratic function with a horizontal translation of 2, and then followed by a vertical translation of -3. Don't forget, if they give you a positive, that means it's moving to the right and, or down, depending on the situation. If they give you a negative, that means it's moving down or to the left. So I know this one will be a quadratic function. So I'll start with x squared, and then I know it moved down 3, so I'm going to put -3 on the outside. And then I know I move to the right 2 units, so I know I'm going to have a -2 inside. And then we can use that equation for k of x. I'll rename this if we need to evaluate with anything dealing with k of x. Okay, so example number 5, it says the graph of the function f of x is given above with tables of selected values for the function g of x, an equation of a piecewise function h of x, and a verbal description of k of x. Use this information to evaluate the following if possible. So again, keep in mind, not all of these will have an answer. If you're not able to evaluate based on the table or the graph, then you can just say not defined. So here when I do g of 3, so this is g right here, which is my table values. My input needs to be 3 and I don't see it. So then I'm just going to say not defined. Since that one was not defined, then the whole composite function is not defined. You don't have to keep going. Okay, for the next one, I'm looking for h of f of 8. So when I look in my graph, when x is 8, my y value is -1. So I'm going to do f of 8 is equal to -1. Now I need to input that -1 into h, so I'm looking for h of -1. So when I go to h, I need to plug it in here because any number less than 1 will use that equation. So when I do it, it's going to be the absolute value of -7 plus 3 times -1. So do the inside first, so that will be -7 minus 3, which will be the absolute value of -10. Don't forget, when you take the absolute value of a number, it's always positive. So the absolute value of -10 is going to be +10. Okay, for the next one, for C, I'm looking for g of k of 0. So I need to find k of 0 first. So that's going to be this equation for k with a description. So it's going to be 0 minus 2 squared minus 3. Well, that's going to give me 0 squared, which is 0, minus 3, which is -3. So k of 0 is -3. And then I'm looking for g of -3. So plug in -3 into g. And then again, g is the table. I don't have -3 on my table, so I'm going to say not defined. And then that will also be my answer for C, not defined. For D, I'm looking for f of 2 first. So f of 2, which is going to be your graph. Don't forget, when you have multiple points, you want the solid dot. So this one goes here. So then the y value that goes with that red dot is going to be 1. And then I'm going to find f of 1. So when x is 1, my y value is 4 in that graph. So I know that f of 2 is equal to f of 1, which is equal to 4. Going back to rewriting them like I've been telling you. For E, I'm looking for g of h of 1. Again, I'm rewriting it, so I need to find h of 1 first. So when I look at my piecewise, when x is equal to 1, this is what I'm looking at. So I know that h of 1 is equal to -4. And then I am finding g of -4. That will be the table at the top. So when x is -4, my output or my y value is pi. So I know that this is the same as h of -4, which is equal to pi. Okay, for the last one, we have a lot going on, but don't forget you can start on the right side. So I need to find what k of 3 is. So plug in 3 into that equation. So it will be 3 minus 2, quantity squared minus 3. So that will give me 1 squared minus 3, which will give me -2. After that, move on to the next one. So I need to find h of -2. So I'm going to go here, and then I'm going to plug it into the first part of the piecewise function. So it's going to be the absolute value of -7 plus 3 times -2, and then close your absolute value. So for that, I'm going to get the absolute value of -7 minus 6, which will be the absolute value of -13, which will be equal to 13. And then move on to the next one. So I need to find what f of 13 is. My graph only goes up to 10, so that will be not defined. And then I'll have to continue going because if one of them is not defined, then the whole composition of functions will be not defined. And we are done. Thank you for watching this video. Hopefully you'll learn something. Don't forget to like and subscribe, and have a great day. See you next time.